Hello and welcome back to Calculus 1. Today we're doing 4.9 Antiderivatives. Hey.
So hello and welcome back to Calculus 1.
I'm not professional yet.
Today's lecture is on antiderivatives. This is a very short lecture because you already know derivatives, and this is reading derivatives backwards technically. So the antiderivatives, we are talking about undoing derivatives. Derivative is the operator. It changes the function. So operations like addition and subtraction, multiplication, they change numbers from one value to another. When you add 3 to 7, you get 10. You changed 7 to 10 by adding 3 to it. When you double 8, you get 16. So you changed 8 into 16 by doubling it. The differentiation and integrals are operators which change one function into a different function. Exception is e to the x. So you have derivative of sine x is cosine x. The operator, derivative operator, changed sine x function into a cosine x function. Now that has all the other implications, right? Everything else we learned. But, you know, in a nutshell, one function became another function because we operated on it using the derivative. So now I want to start by denoting that the derivative of x squared is 2x. And the integral of 2x dx is x squared. Now, this is writing the whole derivative procedure backwards. So we are starting at the answer and we are figuring out how to go back to the original. Not yet. Next example. So now I have x squared plus 100, which is 2x. Now, do you see a problem here, guys? Do you see a problem? What's a problem? Yes, we lost the information. That plus 100. And even if I go and I take maybe subtraction with a constant, right? So x squared minus 3 is still going to be dx. So 2x, and then integral of 2x dx is going to be x squared. There is no way to retrieve this negative 3 and a plus 100 without something is called initial condition. So how do we fix this problem? How do we fix this problem? What do? We put plus c on each one of these. Because if you are not provided with this, the only thing that remains behind are these integrals on the right-hand side. The integral of 2x dx is x squared. Now, there might or might not be some kind of a constant, which is the reason why we put plus c. So this plus c is not there for decoration. You have to put this plus c every time you integrate. Now, integration chart is your derivatives backwards. So what did you learn? You learned that the derivative of a constant is 0. Well, that means that the integral of 0 dx is going to be a 0 plus some constant c, which is the constant that was there earlier. You also learned that the derivative of x to the n is nx to the n minus 1. This is the only one that doesn't match what you're used to. It's xn plus 1 over n plus 1 plus c. So this one you have to memorize. That's fairly new. But the rest is exactly what you covered so far, just backwards. What is the derivative of e to dx? So what's the integral of e to dx dx? Yep. Now, guys, I will discuss this tomorrow and on Thursday. Why you must have dx here every time. Yes, for now you are learning it as a part of notation, but if you don't put this dx here, if you just write integral e to the x and you go on, it's mathematically and concept-wise incorrect. You must have that dx there. And we'll see why. What is the derivative of ln x? Very good. So what is the integral of 1 over x dx? You have to put the absolute values. What is the derivative of sine x? What's the integral of cosine x dx? Plus c. Next one is. What's the derivative of cosine x? So what is the integral of sine x dx? Negative cosine x plus c. Do you guys see what's happening here? So we are just working the derivative chart backwards. And I'm trying to find the summary for this. They have one for trig. I'm not sure if they have one. I have one for exponential. All right. I'm going to put 3 dots here because you are supposed to know the derivative chart, and then you just write out the integral part. All right, so let's go and do 5,000 examples of this. Oh, properties. Hold on. These are important formulas. Integral of c times f of x dx. You can kick c outside. And then you have also the sum of difference rule. So integral of f plus minus g of x dx is equal to the integral of f of x dx plus minus integral of g of x dx. So this one, the first one tells us that we can kick the constant outside, and the second formula tells us that we can do each term of the more complicated example independently of each other. You integrate it. So let's start baby steps, right? We start the easy stuff first. So what is the integral of x to the 5 dx? Now remember, you have the formula up there if you didn't remember it yet. Yes.
Okay, what if there was a situation where it was like, say, 3x cubed or squared, and the integral would be 6x, but the integral would also be 6x for x to the 6th.
Derivatives go power down, integrals go power up. So they always do the opposite thing. So what's happening here? What should I write? That's a derivative. Yep. So it's x to the 6 over 6 plus c. That's all it is. We are using the +1 formula. You have to learn it. One that's boxed. I had x to the 5. It becomes x to the 6 over 6. What is the integral of square root of x dx? What do I do first? Nice. And then we unleash the same formula to get x to the 3/2 divided by 3/2 plus c, and then you make it pretty. 2/3 x to the 3/2 plus c. Show me this line. How much is the integral of 10x squared dx? What do you do with this 10? Kick it out. So 10 integral of x squared dx. So what do I do now? Nice. So how much is the integral of x squared minus x plus 7 dx? What should we do in this case? Yes. So each one of these is separate. So what do we get? X to the 3rd over 3 plus 7x plus c. Now, some of you might be wondering, wait, what just happened? How did I get 7x there? Here's the little calculation that you can run. So let's say you have to take the integral of 3dx. Do we all agree that I can write it this way? I kick 3 outside and I leave number 1 inside the integral, right? Now that number 1 I can write as x to the 0, right? Using algebra. Now do we all see plus 1 happening? 0 plus 1 is 1. So this is 3. 0 plus 1 over 0 plus 1. So your homework assignment is to go to the store and write on the screen 0 plus 1 is equal to 1 10 times. That's the assignment.
Do I get credit for it?
No.
No, but then you don't.
But it's going to be it's going to be really funny. Which is the reason why you're doing it. Microsoft Store in Branchburg. Bridgewater Mall. So, plus c. So this is 3x to the 1 over 1. So when you can remember this now as a formula if you want to, that the integral of the constant dx is cx, constant k, plus c. All right, next question, guys. How much is dx over x cubed? So what should I write here? Nice. We first rewrite this, and then we unleash the plus 1 formula. Let's go.
Why is it over n plus 1?
Well, if you take the derivative, you see it works. Now, we are going to see the proof for that tomorrow, right? Because now we're just learning the mechanics. We're learning the shortcuts to be able to do it quickly. Tomorrow, we are going to see the limit definition of the integral, where it's going to pop up. Well, obviously, you will see that before I saw it because you will do the class prep, but yeah. So, guys, what do I do here? I have x to the minus 2 over minus 2 plus c, and then we make it pretty. Negative 1 over 2x squared plus c. So the negative goes up, right? negative goes up. This is negative 2, goes down as a positive. This 2 was already down. So negative 1 over 2x squared plus c. Plus c. $1 million question. Integral of 6 over x dx. Is the +1 rule going to work? Hell no. So, what happened? Yes.
That man just won $1 million.
While having an attitude. That was the answer. Just rolled it over.
The casual $1 million.
Yeah, the casual, exactly.
Wait, +6 is
Are we rolling to the
People dropped out. People dropped out. I think it starts from 2.
Yeah.
So I'm gonna have with us. First person's name, the rest of them.
What's the answer for this question? So we see that the formula for polynomials doesn't work because +1 would be -1 + 1x to the 0 over 0. That makes no sense. So that can't be used. So what else can we use? Who took notes? Did anyone take notes? ln. So what should I write?
Y equals? I'm sorry, I just. 6.
He just heard ln and his body just starts
6
reacting.
ln.
So we start first with copying the problem to put it in a form where we can recognize it, and then 6 ln what?
ln of absolute value of x.
Absolute value of x. Nice.
Plus 6.
So, guys, absolute value is not here for decoration. You must have that. Understand that this side of the integral has a function which computes values. And in this form of the function, you can plug in positive and negative numbers. If x is -6, 6 divided by -6 is -1. Awesome, right? So negative numbers are in the domain. Once the function is changed into ln x, if you don't put absolute value, you are only allowed to plug in positive values. So how are you going to plug in -6? You used to be able to do it over there. You must be able to do it here as well. We fixed that problem, the problem of the domain, by placing absolute values. Now you are saying, okay, so we fixed everything. What's happening at 0? Perfect question. 0 is not defined on this side, and 0 is not defined on this side either, right? It's a vertical asymptote in both cases. See, both integrals and derivatives, they're opposites of each other, preserve the locations of vertical asymptote. What is the derivative of 1 over x? -1 over x squared, right? It has the asymptote at the same spot. So the asymptotes are preserved, and then you have to make sure that your starting domain reflects the end domain. You remember the derivative of square root of x is 1 over 2 square root of x. Negative numbers can't be plugged on any of the two, right? So that stays, all of that stays preserved. Now the next formulas that I'm going to write are the formulas for the trig and exponentials that have constant a multiplying x. Remember how we said that the derivative of sine ax is a cosine ax? Remember that? So you are going to have the same situation now for integration. Integral of a cosine of ax dx is going to be sine ax over a plus c. Sometimes you will find it as 1 over a sine ax plus c, depending on which way the book writes it down. So if you have a constant in front of the x, which is the argument of either ln or sine or cosine or any trig function or e, that a is going to flow as a division now, not as a multiplication. Integral of e to the ax dx is 1 over a e to the ax plus c. So if you have this a floating around, it is going to go as the division into the mix. So let's see some exercises from, you guys are not in a rush, right? We can stay here till 7:30.
Not at all.
Yeah.
Great.
No problem. Well, 7:45.
We're just gonna take it over.
It's gonna take a little
Where?
Down.
I know how much you love trig. So the question is 39. Integral of secant squared x minus 1 dx.
It is tangent. The minus that. Oh, plus the
Somebody has that big in there.
Your parents know, so we won't. Oh, okay. Someone is good. Do you have a dog?
Yeah.
Your dog is good.
What? I don't know. I think it is. Yeah. Yeah, I know. One of them looked in there.
I've had to do it.
What is the integral of secant squared?
Tangent x
Tangent. And what is the integral of minus 1?
minus x.
So this works out to be tangent x minus x plus c. And now as a student, I was happier with integration than derivatives because I can check every problem. I always, as a student, because this stuff meant a lot and it was all cool, I used to check every single problem. Now you can't really do that for derivatives because you either did it right or you didn't do it right, and you hope you didn't oversee anything. But as soon as I started integrals and I learned that they're opposites, well, for me, immediately, let's just check. And every single problem that I would integrate, I just run a little check on the side. The derivative of tangent x minus x plus c. What is the derivative of that? The derivative of tangent x is secant squared x. The derivative of minus x is minus 1. And the derivative of plus c is plus 0. I don't need that. And look, that's that. This is the reason why I liked integrals much more than derivatives. Because I knew that I could actually walk up at the exam and just say, put the 100 right here, right now. Because every single problem, I knew 100% certainty it was correct, because I take the integral and then I do the check, just take the derivative of the answer. If I go back into the original problem, it is 100% correct. Let's see a problem. This one is interesting, 36, so hopefully it's not going to trip you. Looks busy. 12t to the 8 minus t divided by t cubed dt. What do you think we should do first? What do you mean move it up? Factor? Can't. We can factor, but
You can always factor. Well, t be 8 minus t plus t to the negative.
guys.
Oh.
There's a minus there. So what should I do?
Difference of fractions with the same denominator.
Very good. Difference of fractions with the same denominator, and we are integrating each one independently, right? We have the theorem for that. So we have 12t to the 8 divided by t cubed minus t over t cubed dt. Simplify these first. So we have integral of 12t to the 5, because 8 minus 3 is 5. And then minus t to the negative 2, right? Because 1 minus 3 is negative 2. So what are the integrals? Copy the constant. T plus 1 is 6 divided by 6 minus, oh, come on, minus t to the negative 3, or, plus 1, t to the negative 1 over negative 1 plus c. And then, what do? We simplify. 12 and 6, it's 2t squared. Negative and negative give me positive. 1 over t, and then plus c. Now you can check this by taking the derivative and, oh wait, I put a square instead of 6. This is 6. So if you take the derivative of this and then you add fractions with a common denominator, you must end up with the original problem. Exactly. So one more and then let's go. No one is leaving. I can just go till 7:30. 7:37 and then leave for the be late for the next class. Guys, one more.
We can do this all night. It'll be like no. I was gonna say like something like the Hunger Games, but I forgot.
What's everyone's obsession with the rip-off movie?
Wait, what?
Rip-off movie, Hunger Games. Everyone's obsessed with that. Battle Royale, exactly.
Well, yeah, it is, but people know the Hunger Games, so I just say the Hunger Games.
It just annoys the living hell out of me.
Basically the Hunger Games, except for isn't it high school, right? Like they all get locked in and they have to finish it. Oh yeah, they're all.
Guys, how do I integrate this?
Whoa.
You just foil it.
Exactly. You have to foil. Remember that for derivatives you have the product rule. You can't take independent derivatives in a product. It doesn't work. You have the product rule, which is a formula. There's going to be a formula for multiplication later on in Calc 2 called by parts. Right now, the only thing we can do, foil everything and then integrate independent terms. All right, so let's foil this. What do we get? We get, hold on, x times x squared, so that's negative 3x squared. And then we have 12x minus x is plus 11x. And then plus 4, right? Don't forget dx, guys, at the end. You will see tomorrow why this is a must. And then when you take another course in calculus, Calc 2, it will be reinforced, and differential equations even more. What is the integral? Negative 3x to the 3 over
3
plus 11
x squared over 2
plus
4x plus c.
c. These guys cancel. Negative x cubed plus 11 over 2x squared plus 4x plus c. And that ends this section for now. We have to do one more thing with this tomorrow.
Okay. Part 3.
Yeah, not me. All right, see you all tomorrow. Ciao.